Welcome everyone, we are from Group 42. We are excited to present to you the automatic fish feeding and oxygen regulating system we designed as a team project as a solution to the problems fish breeders meet on a daily basis.
We could identify some problems which pet fish owners and aquarium owners mainly face when raising fish. Among them, we have focused on feeding problems and aeration problems. Meanwhile, leaving the fish unfed while the aquarist is not at home for several days is impracticable. So, they have to feed fish at once for particular days, or they have to request someone to feed them. The amount of fish pellets consumed during feeding is one of the most important considerations in fish feeding. This is because if the amount of fish pellets through manual feeding is incorrect, it can have a negative impact on the fish's health. If the fish are given only little amounts, there may be a considerable loss of fish as a result of malnutrition. On the other side, if the amount is greater than what is required, it might lead to overeating, contaminate the water, and clog up the aquarium's water filters. Aquarists have to face some issues frequently when using non-durable water aeration system in fish tanks. Excess energy consumption due to the activation of aeration system and the extra heat remaining in the water as it is constantly activated are common problems that can be identified. As available solution, aquarists have to turn off the aeration system time to time. They don't have any idea about the required oxygen level of water that fish need for their proper respiration. So, by considering these problems, we have designed the automatic fish feeding and oxygen regulating system. This is our conceptual design of automatic feeding and oxygen regulating system. We have added basic foundation to our system from our conceptual design. To create this conceptual design, we have added a feeding system, an aeration system, and an oxygen measuring device with a microcontroller. We were able to reach every efficient design with the microcontrolling of Arduino Uno, as it can be easily connected to the other systems. Practically, this is very advantageous for the user. This design greatly contributed to the production of our automatic feeding and oxygen regulating system. Our final design is able to achieve most of the analyzed needs. So, the team project is concluded with this design. Let's take a deep look at this design to understand the process and how it is useful. This is our detailed design. Now, we are going to give a brief explanation about the main parts of the system. This is our main control unit of the system. It contains matrix keyboard, OLED display, two Arduino Unos, and RTC. There is a main switch to control the power supply to the control unit. There is a servo motor which is connected to the manual feeder to rotate the screw. It contains a DC motor, crossed hone, output shaft, and several gears. The screw pulls the fluid which drops from the container into the fish tank. The oxygen measuring system measures the oxygen level of the water at time, and it gives the input signal to the main control unit. After that, the aeration system gets the output signal of the control unit. The oxygen measuring system contains Arduino Uno, oxygen dissolved sensor board, OLED display, and platinum electrode. Now, let's see how this proposed system serves us. The oxygen measuring device checks the oxygen level time to time. If the oxygen level is lower than the optimal level, the aeration system starts to aerate the water in the tank. Once the oxygen level is regulated to the required amount, the system will turn off automatically. So it saves excess energy and minimizes unnecessary expenditures. Further, it increases the durability of the aeration system. The owner can feed fish at the correct time intervals by changing the time as needed. When feeding time is over, the feeding system will be turned off automatically. This automatic system eases the work, and it is much better than the manual system. It will give the users mental freedom as they can work leisurely without considering much because their pets will be safe. The system operates in a single-step process with the limited controls, so it's easy to maintain. Moreover, the owner can adjust the parts as needed. Finally, we would like to thank our lecturer Mr. Madhava Herath and our instructor Mr. Dilaka Pitagampala for their guidance and support given to us throughout this project.